Alright guys, so I wanted to do a quick video on acceleration so that we can work on problems in class. Acceleration is a little bit different than speed and velocity. You know, those equations were very similar, but with this it's a little bit more complex. But let's talk about what acceleration is. So typically you would think about if you are pressing the gas, you are accelerating, and you're absolutely right in believing that. That is accelerating. So if you are speeding up, you most definitely are accelerating. However, by scientific terms, if you change speed, you are accelerating. So what does that mean? That means you can accelerate if you are speeding up or if you're slowing down. So let's go back and define what it is. It's actually the rate of change in velocity. Okay, so remember, speed plus direction is velocity. All right, and I'm going to make this pen a little bit bigger so we can see that. All right, so speed and direction are together are velocity. Okay, so examples include speeding up, which we call a positive acceleration. All right, and can you guess what slowing down is? You probably guessed it. It is negative acceleration, okay? And sometimes you'll hear it called deceleration. So remember, like the prefix de means to kind of remove. So this is like removing acceleration, okay? So deceleration. All right. Now here's the kicker. There's another way you can accelerate, okay? And I want you to make sure you highlight this or remember this, okay? If you happen to change direction, you also are accelerating. So there's 3 different ways that you could accelerate. 3 different ways, okay? And you can just make a note. Okay, there's 3 different ways. 3 different ways to accelerate, okay? You can slow down, you can speed up, or you can change direction. Okay, there's 3 different ways you can accelerate. All right, so for example, if you are walking in a circle, okay, but you are not changing your speed, so your speed is constant, right? Remember, constant means, I'm just making notes, if you don't need to write this, you don't have to, but remember, constant means not changing. Okay, so if you happen to one evening go for a walk around the track or around your neighborhood, even if you're walking the same speeds or slowing down or speeding up, you are accelerating. All right, so let's talk about this. Let's look at these examples. If a car goes from 0 meters per second to 10 meters per second, we want to know, are they accelerating? Okay, so from 0 meters to 10 meters per second, I would probably say yes, they are accelerating. So how are they accelerating? Let's think about our 3 different ways you can accelerate. If I go from 0 meters per second, which means I'm not moving, to 10 meters per second, okay, I must be changing speed. So you can either say speeding up or you can just say changing speed. Okay? All right. If a car goes around a circular track, okay, circular is just like this, right? Track at a constant speed, well, I would think that car is changing direction. So I would say, yes, he is accelerating, or the car is accelerating, okay? And it's accelerating because it is changing direction. All right. If a boat makes a sudden turn to the left, so you got a little boat, maybe it's a tugboat, maybe it's a yacht, it's going up, and then all of a sudden, goes that way. Is that a change in acceleration? You bet it is. Okay, it is also changing direction. right, and the last one says a truck slows from 80 meters per second to 10 meters per second. Well, look what this keyword says right here. Slows. So it must have slowed down. So yes, this is also acceleration, okay? And again, it is changing speed. Okay. All right, so now we're going to get into the calculations. It's a little bit tricky, but we're going to work on calculations in class tomorrow. So I just want to make sure we get the formula down, okay? All right, so when we are looking at acceleration, okay, we're going to use the letter A to represent acceleration, okay? Acceleration is equal to your final velocity minus your initial velocity divided by time, okay? So think about velocity. That's kind of like speed, okay? So we are going to write it as such. Acceleration, okay? So I'm going to color code this so you can see, okay? Acceleration, we're going to call that A. So this is A, okay? Is equal to final velocity. So that's your velocity when you're finished, okay? Your velocity when you're finished or at the end, okay? So you can say final, or if you want to say end, okay? That means this one would be your start, right? Okay. Initial would be your start or where you begin. All right, and let's use, I say we use the letter V for velocity. Don't you think? I think that's easy. All right. And since we call it final and initial, we're just going to use the little letters to represent that, okay? So acceleration is equal to final velocity. So this is the velocity when you are at the end, or the final velocity. I'm going to do a little f to represent final, okay? Minus, okay, so I'm following along. So we've got this blue part now. Initial velocity, or the velocity when you start. Let me make this a little smaller. So this is going to be a V. And can you guess what letter I'm going to use? I'm going to use an I, because that's the initial velocity. All right. And then I'm going to divide that by, so this is dividing. Remember, a fraction is just like saying dividing, okay? And I'm going to divide that by time. So I'm going to put a T for time, okay? So that is our equation, okay? I'm not going to go too much into the speed and time graphs. They're very similar to the graphs we did yesterday, except for the y-axis is now speed instead of distance. So I'm just going to write these really quickly. I'm not going to talk about them on these video notes. We'll do a whole nother set of video notes for this. So this is y-axis. If you just want to write these down, if you don't want to write them down right now, that's fine. I just know some people like to not have blanks. Okay, we'll talk about them later. Okay, and then actually, yes, the rest of it is about graphs. So let's stop right there. Let's do one example of a calculation. Okay, so I'm gonna see if I can find a quick problem. Okay, and I'm gonna see if I can throw it on here really quickly, and we do that problem together. Okay. So I'm going to copy this problem. Let's see if I can find my notes here. And we're almost done with this video. Okay, I'm going to put it right over here to the side. Paste. Oops. Let's see if we can put it right down here and make it big. I know you're like, you're not doing anything, Miss Peyton, but I am. I'm doing it on the computer, I promise. All right. Let's see if it showed up on the side. Let's see if we can get it on the side here so we can scoot over and see. All right, let's see if we can get it to populate over here. It might take a second. All right, I'm just going to erase some of this so we can focus. All right, so on this, we're gonna sync this up. There it goes. All right, so let's look at this. I'm gonna turn this way just for a second so we can see this. All right, so here is the problem. Okay, so we have our equation. It says a biker begins to move from a speed of 6, don't worry about this T right here, 6 meters per second to a final speed of 25 meters per second in 10 seconds. What is the acceleration of the bike? So let's go over here and look at our equation, okay? And I'm just gonna copy and paste it. I know you may not be able to do that, but save us some time here on the video. I'm gonna paste it right here. If I can paste it, oops, sorry. We're almost done. Thank you so much for watching this video so we can move fast in class. All right, so here is the equation. Okay, all right, so it says a biker moves from a speed of 6 meters per second to a final speed of 25 meters per second. So which one do you think is the initial speed? Okay, remember initial is the green one, right? This is the green one. And if you said 6 meters per second, you are absolutely right. So I'm going to write that right where it says VI. So 6.0, and this is meters per second. Okay, and then to a final speed of 25 meters per second. So that's probably my VF right here. All right, I'm going to write that right here, 25 meters per second. And then it says in 10 seconds. Well, 10 seconds sounds like a time to me. So I'm going to write 10 seconds right here. So now I'm just going to plug everything in. So let's see how that looks. So VF comes first. Well, let's look. I don't have an A yet, so I'm going to write A because I don't have that. I do have VF. That is 25, and it's meters per second. And then it says I should subtract VI, which is 6 meters per second. And then I'm supposed to divide all of that by the time, which is 10 seconds. All right, so here's the thing. You have to do the stuff at the top first. So in your calculator, you should do 25 minus 6. I'm going to tell you what I get. When I do 25 minus 6, I get 19. So I'm going to put 19, okay, for my top. So I got 19. And then, I'm just going to make this a little bit smaller now. So now I got 19 for that top part. This is what that is subtracted, okay? And then I'm going to divide by 10 seconds, okay? Now this 19 was still in meters per second. So 19 divided by 10, I got 1.9, okay? So this is equal to 1.9. And this really could be pink, right? Because this is acceleration. There we go. And now I have a meter per second. I've got meters per second divided by a second. Well, guess what? That's exactly how we can write it. So this is a meters per second divided by another second, okay? And I'll give you a hint. The way that we say that, okay, you can write it shorthand. You can say 1.9. This is meters per second, and you got two S's, so we're going to say squared, okay? And we'll do more problems tomorrow.